Hello students, we are discussing integration by partial fraction. Let's see what we have in this module. Now the question says evaluate the integral x minus x square upon x square minus 2x minus 3 dx. Let's write the question. Now my dear students, if you observe here, degree of numerator is not less than degree of denominator because the degree is equal. In the numerator highest order term is 2. And in the denominator also the highest order term is 2. So can I say the first condition of partial fraction is violated? So if the first condition of partial fraction is violated, we cannot proceed to apply partial fraction. Now let us see what is required to be done. We know from standard 11 that whenever degree of numerator is equal to degree of denominator, we need to adjust the numerator in terms of denominator. Very well mentioned there, important. It is very important for us to remember this. So let us perform division. Let us use the help of division. Now minus x square plus x, obviously the numerator will become the dividend and the denominator will become the divisor. Because degree of dividend and the divisor is same, the quotient will be a constant. So let us start finding the quotient, and the quotient in this case is minus 1. Let us multiply that with the divisor to get minus x square plus 2x plus 3, and let's perform subtraction, and then we get minus x minus 3 as the remainder. Obviously further division is not possible because degree of dividend is less than the degree of divisor. So let's write it as x minus x square upon x square minus 2x minus 3 is equal to what? We remember it as quotient plus remainder upon divisor. So quotient minus 1 plus remainder plus of minus x minus 3 upon divisor, that is nothing but x square minus 2x minus 3. Are we okay with this? Let's go further. We have to integrate this particular function. So the integral will look like minus 1 or minus of integral 1 dx plus minus of x plus 3 upon x square minus 2x minus 3 dx. Now my dear students, integral 1 is very simple, it's x. So let's write that minus of x plus, I will take this integral separately, so I'll write it as I1 plus E1 because integration is over. Now my dear students, what we need to do is find the integral I1. Let's go to find integral I1. What is integral I1 equal to? It's equal to minus of x plus 3 upon x square minus 2x minus 3 dx. Now my dear students, degree of numerator is 1, degree of denominator is 2. First condition of partial fraction is satisfied. Let's see if we can factorize the denominator. So let us write that in the next step. The denominator can be factorized as, now minus 2x will be written as minus 3x plus x, and on factorizing I get x minus 3 into x plus 1. That's fairly easy, so I will not go much into it. So let us write the denominator as x minus 3 into x plus 1. Now my dear students, denominator also has distinct linear terms, so we can say both conditions are satisfied. Let's apply partial fraction. So let us write that minus of x plus 3 upon x minus 3 into x plus 1 is equal to a upon x minus 3 plus b upon x plus 1. Correct? We need to find the value of a and b, so let's take LCM. Minus of x plus 3 is equal to a into x plus 1 plus b into x minus 3. Now my dear students, you are well versed with how to find the values of a and b. Just make the other coefficients equal to 0. So for a, we will put x is equal to 3. So what we get is minus of 3 plus 3 is equal to a into brackets 3 plus 1. Or can I say minus 6 is equal to 4a, and we can write that as a is equal to minus of 3 by 2. So first constant a is there with us. Now let's go to find the value of b. For b, what should I put? I should put x is equal to minus 1. So we get minus of minus 1 plus 3 is equal to b into, can I say minus 1 minus 3? Correct? So what we have is minus 2 is equal to b into minus 4, or can I say b is equal to half? We get the value of a, we get the value of b. Let's see the partial form. So minus of x plus 3 upon x minus 3 into x plus 1 can be written as minus of 3 by 2 upon x minus 3 plus of half upon x minus 1. Correct? Now let's integrate this. To integrate this, can I say I1 will be minus 3 by 2 upon x minus 3? Correct? Likewise, plus half integral plus half upon x minus 1 dx will be as it is. Let's separate. So what we get is minus 3 by 2 integral 1 upon x minus 3 dx plus half integral 1 upon x minus 1 dx. So now the integral will be very simple. What we will have is integral of the form 1 by x, and that can be written as log mod of x. So what we can say for the first one is minus 3 by 2 will be as it is, and what we will get is log mod of x minus 3. Likewise, plus half log mod of x minus 1, and we write the constant of integration as c2. We have already used c1. We've got I1, we can find the value of I now. Let us write that. What is I1 equal to is there for our reference. Now what was I equal to? I was equal to minus of x and plus of I1 plus of c1. So let us substitute the value of I1. We have it right in front of us there. So let us write that as minus x. Now instead of I1 I'll write minus 3 by 2 log mod of x minus 3 plus half log mod of x minus 1 plus c1 plus c2. So in the next step I'll just rewrite the remaining terms as it is. That's minus x minus 3 by 2 log mod of x minus 3 plus half log mod of x minus 1 plus c, and this is nothing but our final answer. This is how we deal with sums where degree of numerator is equal to degree of denominator and the denominator can be factorized. That is, partial fraction can be applied. What you need to do is practice a sum of the same type. That's all we have in this module. Thank you very much.